Your ability to hear and balance are both controlled by things in your ears. In particular, what we look at here are mechanoreceptors. So this is movement. And we get sound waves coming into our ear through the outer ear. It's funneled in to this auditory canal, which is air-filled. Hits your eardrum, also known as your tympanic membrane, moves the middle ear bones, and which is also an air space. This middle ear is air-filled, and sends the signal through to your cochlea in your inner ear, which is fluid-filled. So when we look at your external ear, its whole purpose is to funnel sounds in. And it's primarily cartilage covered in skin, and getting that sound filtered into your auditory canal so that it can come down and bounce sound waves against your tympanic membrane or your eardrum. When it does that, it's going to turn those air waves, those sound waves, into mechanical movement by moving these ossicles or bones of your middle ear. And when we get that vibration set up, here is your eardrum. You can't see your eardrum this well. This is a very, very straight and wide auditory canal. But you do see some earwax here. Yummy. The idea is those airwaves come in, sound waves come in and hit that eardrum and send that information into this middle ear chamber that is primarily these three small ear bones or auditory ossicles that are going to take that wave information from the air and actually make it into mechanical information that your cochlea will be able to pick up. We do look at this area being cleaned constantly by your eustachian tubes. If you had ear infections a lot as a kid, these eustachian tubes become blocked and the mucus builds up and causes infection. So if you had a lot of ear infections, this might be why. And some individuals now, some little kids especially, will get tubes put into their ears, so literally a hole through the eardrum that's going to allow that fluid and infected fluid to drain out. And eventually, when they get past the age of having issues with this, they'll take out those tubes. In the meantime, hearing is affected, of course, by the eustachian tubes blocking and building up fluids in this middle ear space that is supposed to be air-filled, because we need these ossicles or these bones to move properly. And the bones are referred to as hammer, anvil, and stirrup. Or some of you may know them as malleus, incus, and stapes. This is what they look like taken out of an individual, and ear bones are actually pretty interesting. They found recently in fish that you can actually figure out how old a fish is by the rings on its middle ear bones. Like tree rings, they build up layers on their middle ear bones as they age. Kind of cool, something different. And we need to get that information, as we said, from the air, the outside environment, in through to the fluid-filled cochlea. And this is where we're going to find our mechanoreceptors, finally, to send information to the brain. Okay? And remember, if a sound is louder, it's because of more action potentials, not because of a change in the action potential height. So what happens when you lose your hearing? Well, it can be caused by any number of things. It can be genetic, right? You can be born that way. because of some sort of difference in your formation of your ossicles, the formation of your cochlea. There are all kinds of issues. There may be difficulties with your auditory nerves. But if you develop deafness over your lifetime, some are because of those middle ear infections as a kid. Too much infection has impacted the hearing over their lifetimes. A ruptured eardrum or stiffening of those middle ear bones so they don't actually vibrate and move as they're supposed to. Things like ear infection and ruptured eardrum deafness can be potentially repaired over your lifetime, but we don't always see it. Sometimes it's permanent. As you age, you have issues associated with damage to sensory receptors or the neurons themselves. Simply, things are getting older and less pliable and viable to transmit information. So this is what we would look at as progressive deafness and eventually potentially becoming completely deaf. Many people often report just a loss of particular frequencies or amplitudes of sound, pitches of sound over their lifetime. Maybe they can't hear very high-pitched things or very low-pitched things with age. What we look for to actually transmit this information in your system, like we said, is in your cochlea. We also look at this same area being associated with balance and equilibrium. So we have 3 specific organs in your inner ear associated with your cochlea. It's your semicircular canals, your utricle, and your saccule. So we look at these in your inner ear associated with balance. So this part of your inner ear is associated with balance. This part of your inner ear is associated with hearing. But inside both, we have hairs. And those hairs are what are the mechanoreceptor connections. So down here, we have all these nerve fibers coming in. These are mechanoreceptors, and they're picking up movement. So whether it's movement because the middle ear bones have attached to the cochlea and have moved the fluids inside here, or whether it's because of our movement of our head, our balance and direction. You notice with the semicircular canals, we have X, Y, and Z planes, so you get 3-dimensional orientation of your head based on that. But all of them are based on the moving of these hairs. And as we age, these hairs get shorter and shorter and shorter. And that's what leads to some folks having difficulties with hearing as they age and also balance as they age. Some of you may have vertigo or the sensation that you're constantly moving even when you're standing still. This has to do with the fluids moving inside those organs and constantly telling you that you're moving. Some of you are prone to motion sickness, and this is associated with the idea that you have some sort of miscommunication between your eyes and your inner ear. And often this is remedied to some extent by simply closing your eyes and letting your brain decide what's up and down and not being confused by what you see on a rocking boat or a moving plane.